This is Laura Sullivan-Russett with Part 3 of Networks Programming Assignment 5, demonstrating the project for my partner, James Tomasko, and I. So like in previous videos, I'm going to run this simulation first. And then I've actually saved the output into a text file because it's a lot easier to see it in a larger font, and just so that I can show exactly how our packets are being forwarded, and the fact that the priority 1 packets are delivered first, followed by the priority 0 packets. So you can see that this is running to completion. We extended the simulation time to 25 seconds to make sure that there was time for H3 to get through all of the message it was supposed to receive. So here is the output file that I sent a previous run into. And as you can see, there is a queue when both host 1 and host 2 are sending to router A. And you can see that in our output here, we count there are 3 priority 0 packets and 1 priority 1 packet when the queue is size 4. And that's because the first priority 1 packet is already being sent. And so you can see now that the priority 1 packets are sent first. We chose to put the priority at the very end of the packet so that it would be easy for us to access. And so anything that ends with a 1 is a priority 1 packet and is being sent through router B. And then anything that is a priority 0 packet is going to be sent through router C. And so you can see here there's the priority 0 at the end, and this is going through router C. The other good place to demonstrate the queue is at the very end where there's a bottleneck in D. And so once these messages start getting to router D and it tries to forward them on to host 3, then it gets a queue, and you can see here that by the end we've got 5 priority 0 packets in the queue and no priority 1 packets because all of the priority 1 packets have already been sent. And so you can see that H3 receives message 3 with priority 1 from host 2 before it receives message 0 from H2 that was priority 0. So the way that we implemented, we did quite a bit of modification to the interface class. We added some variables to it so it could count how many packets of which priority were in its queue at the time. And then we used that priority to determine that all of the priority 1 packets got sent through before the priority 0 packets. And so, and we incremented and decremented the priority count in the get and put functions. And so we were always able to get an equal number of packets of priority types to add up to how many packets were actually in the queue. So in our network packet here, you can see we did add the priority variable and added it to the byte string and added it to the ability to create a packet from the byte string. We did not add that priority to the MPLS frame as was specified in the instructions. And then in our process MPLS frame function, we extended the label in the MPLS frame to be the full name of the destination router. And so for packets that were labeled router B, those are the priority 1 packets, and so they would be sent through the out interface that goes to router B, and if they otherwise they would have the router C label and they would go out through the interface that connects to router C. And so in the link .py, we also modified to make sure we could display those priority counts. And so you can see here we've got access to those priority counts through the router or through the interface that has that queue, and printing out the number of priority 0 packets and the number of priority 1 packets. And that should be about it. So thank you.